Okay, are we coming through? Is the signal all good? You want to check and see if it's good on your end?
Okay.
Okay, because we're not letting this happen again like it did the other day. Hello there, everybody. Ryan Sapinski here, along with Brianna. Yeah, you got to peek in.
Hi.
There she is. Okay, all set to go here. All right. And we are here for a special take two of what was originally Friday's live stream here on the channel. Okay. And we're doing this because if you attempted to watch Friday's show, I happened to discover late last night as I was working on my stuff, as I've talked about on Facebook or whatever, that for some reason I didn't know that our Wi-Fi connection was very bad that day. How bad? Bad to the point where a half hour of the footage has since disappeared. So that's yeah, not good at all. So, and we are determined to give you the absolute best math content possible you could find anywhere, live and unscripted and stuff like that. So we're gonna do it again. Okay, everything we did on Friday, we're gonna do it all from scratch here and stuff like that. Along with, we're actually gonna lead off this stream with with one new topic that we didn't originally do Friday, and this is something that a friend of ours submitted on the Algebra 2 level. That I want to make sure that she's gotten. This student has an answer. She's waiting to see if she got it right. I promised her we'd start the stream so that she could check and see how she did. So Emma, if you're watching, brace yourself as we go through some zaniness. And anybody else that's popping in, you want to throw an extra topic in, we'll still do some more stuff if you want. I want to still have some fun with this here. Okay.
Yeah.
To submit to the live chat here on the side. I'll still be okay, and I'm just making the reminder here. Okay, as well as at brian.sapinski@gmail.com. I'll be checking over there as well, just to get everything all situated. All right, so to start off this new question here, now let me lay a little bit of the groundwork here. So because like I said, Brianna is still in 5th grade. So okay. So here's what I know too. We talked about percents, Brianna, and some of the past shows. Okay, so answer this question for me first. Okay, all right. How much is 8% of 100? I'm choosing that specifically just to kind of lead things off here, because we talked about percent of a number and things.
80?
Okay, 108. No, wait, that would be 80% 100. Remember.
8.
Yeah, because remember, what did we say 8 was as a fraction? It's 8 over. Right, yeah. Percent always represents the number of parts of 100 that you have. And we've always stressed that of represents what operation?
Times.
Right, times. So 8 over 100 times 100, those would essentially knock each other out, and you end up with 8. Now, building off of that, now follow this. Building off of that, if I asked you this alternate question, knowing that 8% of 100 is 8, if I asked you what is 8% more than, not 10, than 100, okay, how much would that be? We already know that 8% is 8, so what's 8? Okay, so it would be 108. And this would be the equivalent, and to turn this back into percentage, this would be the equivalent of 108% of what you started with. Okay, so think about that thing. And what would 108% be as a decimal? We talked about changing percentages and decimals here because I had some people asking me questions about that. Because remember, if 100% represents one whole, right, 1.08. Okay, that's what we want to see. This number is going to be important to us for the question that our friend is asking about, because this number was part of the problem. Here was the scenario. Here was the Algebra 2 scenario now that that our student friend was asking us here. Okay, the question was talking about a company that was contributing money into some kind of into some kind of bonus or retirement fund. I forget the exact phrasing in the question. Something about a. Oh, wait, that's right. No, wait, I got the question right here. That's right, because they sent it to me. I'm sorry. Why am I trying to make up the details of the question? I forgot I have the question here. Okay, yeah. A company is starting a scholarship fund for its employees. The company will add to the fund on a yearly basis. Each year, it will increase the amount added to the fund the previous year by 8%. So that means whatever it is that they added in year one, that means in the next, so in year one, they're adding one whole or 100%. The next year, they're adding 8% more, or 1.08. And this is the result of taking the one and multiplying a 1.08 in. Then the next year will be another 1.08 on that, whatever that is, and so on and so on. So that's the way this is working. Now the question says that after 4 years, the fund has in it 2,000. Make sure I read this number correctly. $2,928 and 97 cents. I'm sorry, 97 cents. Okay, so the question wants to know if this is how much was in there in 4 years. How much money was donated to the scholarship in year one? Okay, now because of the fact that there is a repeated multiplication happening here, okay, this creates an example. We talked in some of the previous ones. You remember before when we were doing arithmetic sequences, where to get from one number, you remember the ones, remember the one I had you do alone for a second when I was late to the show, where the idea was to get from one number in the sequence to the next, you had to add the same amount over and over again. You had to keep doing that and so on, all that business. You remember that? This is an example now where we're multiplying the same amount over and over again to get to the next number. So this is an example of what is called a geometric sequence, okay? But we're not just going to strictly be talking about just doing the multiplication, figuring out what this one is, what that one is, and that one is. What we're going to do is, since this is a total of the first 4 terms of a geometric sequence, that gets into what's called a series. A series, and arithmetic sequences have series formulas also. The idea is that when you have a pattern of numbers where the number is repeatedly added to the added by something gets the next thing, or multiplied by something to get to the next thing, if you keep a running total of all the numbers in the sequence to that point, that's a series. So like in the example I just had here, Brianna, so if we were doing an arithmetic sequence of +7, if I wanted to get a series, after the second term, I add those two, I've got 15. Then the next term of the sequence, 18, add 15, 18, and you get
15, 18.
Go ahead. You can just tell me. Oh, come on, you know this. Yeah, 33. Okay, and then 20, and then 25, and then 25 for the next one, and 25 for the next one. So the total would now be 58, and so on and so on. Okay, so that's how an arithmetic series would look if you were adding each term individually. For a geometric, it's the same thing. But the problem in this one is we don't know what amount we started with. So we need a formula in order to help us get there. The formula for a geometric series looks like this, okay? We use this term, capital S with a subscript of n, to represent the total of all the terms in the series after n number of terms. And here's the way the formula reads. It's A1, and we've seen this before. A1 represents the first term in the sequence. It's multiplied by 1 minus r to the n power. I'll talk about what r is in a second. And on the bottom, you have 1 minus r. What r stands for is what is called the common ratio. And what that stands for is basically what are you multiplying by over and over again. In our example here, this is what we're multiplying by, the 1.08. So this is our r. Okay, so for everything we've got here, we could fill in a few different things. here's the details that we know. We know that the ratio is 1.08, so we can put that here and here. Okay, so we've got 1 minus 1.08 there. We got 1 minus 1.08 there. Okay, we don't know A1. That's what we're trying to find. Now, we also know the value of n, because how many years have passed? How many years have passed in this problem? According to the details?
4.
Okay, so that means the n here is going to be 4 years. Okay, so we're going to put the 4 right there. Okay, and we know what the total of the series is at this point. How much is the total at this moment?
The total is
The 2000. Okay, so the 2000. Okay, well here I'll leave that there just to keep the formula intact. Okay, so $2,928.97. Okay, so now we've got enough here that we can algebraically work our way backward to get the A1 by itself, and therefore to successfully solve for it. Okay, so here's what we're going to do first. Okay, first, and here, use your calculator for this because this is going to be very calculator dependent. All right, calculate 1 minus 1.08 for me. Should be pretty straightforward.
Can you repeat it?
Yeah, this one, 1 minus 1.08. Okay, so this part gives you negative 0.08. Okay, now it's at the bottom of the fraction. We've talked about in simple algebraic equations before that if you at the bottom of a fraction means what operation? Say it out loud. Come on, you know this. Division. She's so shy and nervous here that she's going to get it wrong. You've been getting it right every single time. Why stop now? Okay, so how do we get rid of the division?
With multiplication.
Okay, all right, so we have to multiply that now to the other side. Okay, so times the negative 0.08. Okay, so punch this in. Punch 2,928.97 cents. Okay, so here, wait, let's do this. Put the 0.08 in first. Put the 0.08 in. Okay, hit the plus minus key to turn negative. Okay, times, and now the $2,928.97. 2009 wait, back it up. Wait, hold on. Do it again. 2009.28. Not.
But then
No.
it clears everything.
No. If you hit the second time, it clears everything. There's clear and there's all clear. Okay, that's okay. It's fine. It's fine. Don't worry. I've said plenty of people do that. Okay, 2009.28. 2009.28 and 97 cents. Okay, and okay equals. Okay, and so we have that number. Okay, it looks a little complicated, but don't worry about it. We've got read off negative. Was it say negative 234? Read that decimal for me.
0.3176.
Okay, so we got that. Okay, now as far as what's on this side, now I want to calculate this part. Okay, now this is going to be a long decimal, but hang on to it. Fix my wave bracket there. Okay, so here's now what I need. Okay, because now we got to calculate 1 minus 1.08 to the 4th power. Okay, so here's how we're going to do this. Okay,
yes.
All right. In your calculator, all right, yeah. Now hit the all clear. Okay, in your calculator, I'm going to do the exponent part first. Okay, so or as a matter of fact, here I'll tell you what. I'll save you some grief. I'll do this one because I could get it all in one shot. If you calculate 1 minus 1.08 raised to the 4th power, okay, there you see it there, and you see the very complicated decimal that we get here or whatever. Okay, so, and I'm going to save that because we want to keep that exact number. Okay, so okay, well here I'm gonna just bring it right down here because we need it there. Okay, yeah, save room for it. Okay, so we got negative 0.36. Move my arrow there. 0.48896. And our A1 is right there, and it equals this. Okay, so now to finish it off, to fix the A there. I'm always messy with lowercase a's. Okay, so now you have a multiplication here, Brianna. You have a multiplication here. And so to get rid of a multiplication, we need division. So all this long, busy decimal is going to divide into that negative 234 and change. So we're dividing by negative 0.360488896, not 9. Stay the way you are. Okay, so as a result, we end up with, okay, and whatever this division is, that's the amount to the penny that was given on the first one. And I know that I have the answer here or whatever, so I'm not going to bother trying to punch it into the calculator. So if you did all this, then you should have gotten the proper amount of what was put in on the first day, which came out to, when rounded, it came out to exactly $650. So that's how much was put in on that very first go. Okay, so Emma, if you got that, you're doing fine or whatever. If you got any way to throw into the chat and just give us some kind of approval or send me a text or something like that, just so I know you got that answer, because that's what you should have gotten, and hopefully then you are okay. All right, so that was part one. Now, there was a second part to her question, okay, that also plays off this geometric series formula, okay? What it said in the second half of the question was, okay, forget this 4 years, okay, and let's suppose that instead of starting at 650, it then gave us this detail. What if instead, she says, yay, she got it right. Okay, so now here's the second question, all right? What if instead of 650, Brianna, what if in year one they started with $1,000? They still went up by plus 8% every year, et cetera, okay? And the question wants to know, what is the average amount, rounded to the nearest dollar, the average of what was put in year to year after 10 years, okay? We'll talk about the average part in a second. Let's deal with this formula again. This time, the calculation is more straightforward. Here's what I want you to successfully determine. Okay, you get this settled, and I'll take it from there. Okay, I want you, Brianna, to set up the numbers in the formula properly, because from the details that are here, you've got enough to fill in all these variables. Okay, so first, what's our A1? What's the amount that we put in first here? I'll let you write it.
1,000.
Okay, so start the 1,000 right there. So 1,000 goes right here at the beginning. Just put it right there. Okay, I was gonna say, yeah. Okay, all right. So all right, now we got to fill in the parentheses. Okay, let me give you a longer fraction bar. Okay. So the 1 minus is guaranteed there. The 1 minus is guaranteed there. Okay. Now, just like the last problem, what was that amount that we had in the R position? Because that number is still the same. Okay, well, it wasn't just the A. Remember?
Percent.
Well, okay, but wait. First, what was 8% as a decimal? Point what? 0.08. And remember, it's an 8% increase, so we had to put the 1 there. So it was 1.08. Yeah, no, yeah, the 1's fine. Yeah, 1.08. Okay.
Oh, wait, not.
She learns her chicken scratch from the best folks. Okay, all right, and again, here's an R down there, so it goes over here as well.
R?
Yeah, so no, the 1.08. See, both of those are R, so 1.08 goes down there. Now the only thing that's missing, okay, now the only thing that's missing is the value of n, the exponent. According to our details, okay, what's the only number we haven't used yet? That's going to determine our n. What's the only number we haven't thrown into the mix yet?
The 10.
The 10, the number of years. So here, just move that. Okay, put the 10 exponent on that. Okay, so this is the way everything should read. Okay, so when all this gets calculated, that's going to give you the grand total of the first 10 terms of this sequence. That's going to give you the full series. Now, I would recommend, just to avoid, especially with a 10th power, I would recommend, if you have a calculator that could show the whole thing in one shot, just punch in the whole thing at once here, because that's what I'm actually gonna do here. It'll save you a big grief, and make sure you get the exact amount. So 1,000, okay, then parentheses 1 minus, okay, 1.08 exponent key 10th power, close parentheses, divided by, okay, just so you can see what it says so far. This isn't the answer, but this is just the top half on its own, just so you can see it. And then on the bottom, divided by, new parentheses, 1 minus 1.08, close the parentheses, and so we end up with, okay, now, and rounds it to the penny. This is the total of what is in the account after the 10 years. We get this amount, 14,000. So we get out of this $14,486.56. Okay, now that's the series. That's this amount. But the problem is, we're not done here, because the question didn't want to know how much was the total amount in the. It didn't want to know how much was the total amount in the scholarship. It wanted to know the average amount contributed in the 10 years. So at least the good news, though, is by doing this series calculation, we've performed the first half of an average calculation. Because Brianna, she's a little off in the distance here. She's grabbing a drink for herself. When you calculate an average, the first thing you have to do is to divide. Right, I gave away the answer. I'm human too, folks. The first thing you have to do is add up all the numbers that you have in the data. After you do that, after you've gotten the sum of them all, then what operation do you do to that sum to get the average? I kind of gave it away a second ago. I slipped and said it.
You did?
Yeah. If you know what it is, holler it in there. You know, feel free to chime in. So like if I want to get the average, Brianna, of say 3, 4, and 8. If I want to get the average of those, I have to add those up. I add those together and I get that. But then on its own, the average of those is not 15. How many numbers are there?
3.
What do I have to do with that 3?
You divide it.
Divide it. Yes. Okay. In this case, I'm dividing this by what? How many numbers are in the set? Again, what was our key? We're getting the average of 10 years. So divide this by 10. Okay, so you get that. And so in the end, you get $1,448 and rounds it off on the penny, 66 cents. But the question wanted, what Emma's question wanted to know is round that off to the nearest dollar. Okay, so round it up to nearest dollar. What's it going to finish as? 1,400 and $49. Okay, so that's the average per year that was contributed there. Okay, did we go 2 for 2, Emma? I hope we did. So because that's how that one should have played out there. So yeah, it's a quirky formula when you're dealing with when you're dealing with this, because now we're getting exponents into the mix and it goes all a little bit crazy and stuff like that. But as long as you've got the key details that you could put everything else in its proper places and stuff like that, then woohoo, we got a woohoo. So everything's all in the books there. So
yay!
See, we got you through, Emma. I'm glad you saw it. Yeah, you had the right idea of what you needed to do and how you had to plug stuff in, both forward and backward between the two questions. Yeah, I told you that these were the easier ones compared to the other one that we were talking about before this stream. But
yeah.
So no, I'm glad that you got through it and everything was all nice and fine there. So It's all good. And here, I'll tell you what. Stick around for a minute because
Yeah,
I
we're
want to.
gonna
I want
have
to.
some fun.
Well, okay, but before that, all right. I want to do the. I want do the geometry problem that we demonstrated the other day. Remember with the helicopter?
And so cool.
Okay, yeah, I want to do that because no, we talked about it. I want to make sure we could see it in full. Okay. Yes.
Oh, no, it's
Oh
not
yes,
big
that's right.
enough.
That's right. We created this on Friday originally. Yes, we are flying the official flag of the nation of Sokotoa. The flag is the flag is a right triangle with the symbols in it and stuff like that. Yeah. So yes, this is the official flag of the nation of Sokotoa. That's what we
Yes.
that's what we have here. We're gonna have to design that now. We'll have to get well here. Wait, you've done some you've done some practice sewing here or whatever. You probably have to try to make an official flag for a to fly in the future show. I'm sure we'd love to see it.
Is that no? That's not how you spell it.
Wait, wait. AH here, and there's it's SOH at the beginning. SOH CAH. CAH. The TOA was fine.
Like this.
Wait, yeah, no wait. CAH TOA. You had the TOA part right.
No.
The lyrics again. Wait, no, wait. Your H is too low here. Might as well sing it that way. Sokotoa. Sokotoa. All crazy there. Yeah. Anyway, okay, all right. Okay. The point of it all was that my geometry students, they were going through they're going through their lessons in trig over this past week and so on and things like that. But for the first time, they're starting to see word problems. So, and I was giving a demonstration on here on Friday, and I think a lot of it actually got cut off as to how to set up the details of the problem here. And borrowing from our official textbook that we use for the class, I was using one of the practice problems that they gave in the question there. So the question that they asked set up this problem. Okay, a search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. Okay, so here, draw our helicopter again like you did the other day. Okay, all right, and I'll set so you draw that, and I'll set the right triangle going this way and stuff like that. Okay, chopper one. So get. Oh, I see. Okay. While she's doing that, I'll fill in the details of the problem. Okay. They say that the helicopter is 18 feet above the water. Okay. They set that up, and they said that the person, the person that they have to rescue, you know, that's over here, yeah, floating in the waves here. Is at a 42 degree angle of depression. God, I can't spell tonight. A angle of depression from the thing. The question wants to know what is the horizontal distance. What is the horizontal distance along the water from where the helicopter is to the person that they need to help? Okay, so
whatever. I just like
okay, so relax, it's fine. All right, so here's the detail. All right, so let's recap the details of what
harness. So I just made it a giant claw.
Okay, I got that. All right. Okay, so let's recap the details of how this was supposed to go. Okay, so the question here was this. All right. So from the details as they give it in the problem here, all right, it says that the helicopter is 18 feet above the water. So that means that as you look at the triangle, now the whole idea is when you read the details of these kind of problems, you got to try to use common sense to help dictate to you exactly what described here represents something that is vertical, something that is horizontal, or something that is slanted. You're always going to be able to fill in 2 out of these 3 sides in every individual circumstance. In the first case, 18 feet above the water. So this means that that the helicopter is 18 feet high above the ground. Which of the 3 lines in the triangle, as we said, represents that 18-foot height? Okay, the line that goes straight down. Okay, so that means our 18 is going to go right there. Now the question.
Little landing.
But huh?
Wasn't there like a landing?
No. This is what we drew. We drew the helicopter.
Yeah, and there's also a circle landing pad.
No. There is no landing pad. This is hovering in the air right now.
Oh.
No. Okay, now the question wants to know the horizontal distance. The question wants to know the horizontal distance between where the helicopter is and where the person is. Which of the 2 remaining segments of the triangle is the horizontal one? Horizontal means going in what direction? Straight across. Okay, so this is our unknown. That's where our x is. Okay, here, I'm just going to move that over slightly for a minute. Okay, the key now is this, the angle of depression. Now, there are such things as angle of depression, such as this, and there are also angles of elevation that exist as well. Okay, and I'll give a fast example of one of those in just a minute. Regardless of which one you're looking at, the rules for both of them are consistently the same. Is that in the case of both of them, whenever you draw these right triangles, both of these types of angles, I like to refer to them as the flat angles, because of the fact that both of them are measured from wherever the flat side of the right triangle is located. And part of the reason for that, and you remember when we first tried to explain this, when you measure up with a protractor, when you measure an angle, okay, you put the corner of the angle right here in the middle, and you measure straight across to here. You make sure the bottom line lines up there. But that flat represents 0 degrees. To actually measure the angle, then you trace upward along the protractor, and whatever number of degrees it is there, that's what you get. But the fact that you travel upward to reach it, that makes an angle of elevation. But it starts from that flat side. To get an angle of depression, it's the same thing. You start from the flat and you go downward to get the other half of the angle measurements. So like I said, that's elevation, that's depression. But they both start from the flat, hence why I call them the flat angles. So here's your flat side. That means that the 42-degree angle is connected right there. So that's what's going to happen. And it doesn't matter which way the triangle is drawn either, okay? The fact that it's drawn this way, it makes it look like, but wait, that's an angle of elevation. Wouldn't the depression be up here instead? No, it would not. Because again, you're measuring from a vertical here, not a flat. That does not constitute an angle of depression. It always is based on the flat side here. If it helps you to visualize it a little better, as I pick up my pen cap, if it helps you visualize it a little better, what you could always do is you could always draw a second triangle coming from this way and straight down. So you kind of, in effect, have a rectangle going here. And the thing is then, up here would be your 42-degree angle of depression right there, because then here's your flat side right there, okay? And then your x would transfer to this side up here based on opposite sides of a rectangle being congruent, and the 18 would transfer over here. It's the same right triangle as the one we drew to begin with. So it doesn't matter whether it says either which one of these it says. Just look for the flat side of the right triangle in the problem, stick the angle attached to it right there. That's what we got. Now that we've got that in place, again, regardless of which way you look at it, now let's get to the actual SOHCAHTOA business, okay? As we saw it, where's the 18 in relation to the 42? Is that the opposite, the adjacent, or the hypotenuse? Is it? Wait. Remember, we said the hypotenuse is the long side. Okay, we don't have anything listed on that, so that gives us that eliminates the Okay, well, adjacent means next to. So which one of these is next to the 42 degrees? Well, no, I'm saying, which one of these is next to the 42 degrees? Okay, so this is the adjacent. That makes the 18 the opposite, the one that's not connected to how the angle is made. So it opens up to that. That makes this the opposite. So opposite and adjacent means, according to the national anthem of... Which one are we dealing with an opposite adjacent? OA. Is it sine, cosine, or tangent? Sine, cosine, or tangent? It's tangent. Okay. So your equation would read as follows. It would read as tangent 42, your degree measure, okay, equals, and putting the opposite over the adjacent, you have 18 over x. It would go in that order in this case. Now, here's where you then have to execute the algebra in order to solve for the value of x. This one is a little quirky because in a rare circumstance, the x is at the bottom. We're used to it being on the top. Now, normally with a division, you would cancel by multiplication. That's exactly what would happen here. We would multiply this x over to the other side. So that goes over here right in front. But then what would happen is now you got a multiplication here. To cancel multiplication, we said before we need division. Okay, so we'd have to divide the tan 42 over to the other side. And basically, notice what happened from where we started. The x and the tan 42 traded places. They swapped. So this is what we would have to punch in to try to solve for it. And when you punch this in exactly as it reads, rounds it off to the nearest tenth or whatever, you end up getting about 20.0 feet on the nose. It comes out, pretty much almost exact. So that's what the horizontal distance that we were solving for happened to be there. Okay, so that's how that type of question played out. We'll do the other one that I demonstrated real quick, and then we'll move on to your stuff and play our game again. Yay. Okay, so take a look at this, and now consider this other circumstance. Okay, this was the other problem that I demonstrated. Okay, so the question was, okay, we had a 12-foot ladder that was leaning on a wall. Mm-hmm. Okay, we said it was leaning on the wall at a 65-degree angle of elevation. Yeah. And the question that we asked was, how high up the wall does the ladder reach? Okay, so as we reset, as the helicopter is now saved the person in need of help, and it flies off into the distance. Right here, I'm okay. So we set up our problem again here. Okay, so in this problem. Okay, well, here, wait. All right, well, here, while you draw, answer this for me. A 12-foot ladder leaning on a wall. We said before, as we initially did it, which of the three sides of the triangle would represent that leaning ladder? This. Okay, right, yeah, because the key word is leaning. That means it's going to be on a tilt, on a slant. So that means here's your 12 right there. Once again, angle of elevation. Once again, that's, as I said, that's a flat angle. Here's your across. That means the angle is going to be connected to it, going up just like that. So there's 65 degrees. And then how high up the wall of the two remaining sides? Which one? Oh, jeez. I'm flying. You think he'd pull him into the helicopter? No, we're just gonna let you swing in the breeze all the way till we hit land. God. Really? You serious? God. It's terrible. Cutie, are you looking at this? She's over in the kitchen. Take a look here. We were just talking about a problem where they were rescuing somebody who was in a helicopter was rescuing somebody who was in a boating accident in the water. They got him saved or whatever. Don't even bother. Look at the picture. Wait, pull back so you can see it. Don't even bother pulling them into the helicopter. Just let them hang and fly until they hit land. All right. Which of the two remaining sides, save us from this madness, Brianna, which of these two sides represents the wall?
This one.
A wall travels straight up. So there's your X, there's your unknown. Okay, once again.
Wait, I can make it better.
SOHCAHTOA, which one? Which one we got here for SOHCAHTOA? What is X? Is X the opposite, the adjacent, or the hypotenuse? Wait, is it connected to the 65?
Yes.
Wait. By connected, I mean remember, by connect, is the X sitting next to the 65?
Yeah.
No, it's not. Okay, that makes it the opposite. Because, the opposite is the only one not connected.
He's
and what's
wearing
the 12?
a harness, so it's safer.
Yep. I know of somebody up in the heavens who would beg to differ on that. I'm not going, but I'm not going there. Save it.
It's a good harness.
Yeah. So was that one supposed to be? But
a better.
Hush. What's the 12? The adjacent or the hypotenuse? The slant we always said was which one? The slant is always the. No, wait. Remember, the long side. That's the hypotenuse, right? Okay. Opposite and hypotenuse. OH. Find it. Sing the national anthem and find it. So which one is it?
Huh?
Is it the so, the ka, or the toa? So the sine. Okay. So you have sine 65. This time the opposite is the X. That goes on top.
It looks like he's just wearing a shirt.
Oh God, you're not going to let this go, are you? And neither is the harness, apparently. All right, okay. Solve for X.
He also has another line.
All right, solve for X so we can move on. Okay, what do we got? How do you solve for X? How do you get rid of the 12? This one's much simpler. Say it. Multiply. Okay, so if you calculate 12 sine 65, you'll get the value of X. Make sure your calculator's in degree mode to do this, folks. And we get
whatever that means.
Okay. 12 sine 65, and you get approximately rounded off. X comes out to about 10.9 feet. So that's the way that sets up here. Okay. All right. We got through the busy stuff. Okay.
He's not strong enough to pull him in.
That's why there's never mind. I'm not going to even bother.
There is multiple people.
Yeah, one has to fly the copter, though.
Yeah, this one.
Oh, good Lord.
Wait, I have an idea. Okay, so
we bring math to life in the weirdest ways here, folks.
So,
okay,
this
so
is the thing that makes it you know what I'm talking about with this, right? Where that thing where you put rope onto it, it kind of looks this, and this is where the rope would go. That kind of thing. This kind of thing. This kind of thing.
A pulley.
Yeah, a pulley. They're using some pulley to put the rope back into the helicopter and pull them in. Is that better?
Pulleys and winches. I mean, yeah, no, that's.
They're trying.
I gotcha.
They're trying. Oh, and this guy is also holding the rope just in case.
All right. Okay. So like I said, so we got the complicated stuff here. All right. Now for the stuff that was that. Okay. Good. You wanna?
Huh?
Let's text Elise again so that she's aware and watching and stuff like that. So anyway, all right. So Brianna and her class were working on decimals and stuff like that. One of her classmates was asking, could we go over some decimals basics or whatever, and I promised we would. We tried to before everything went crazy with the cast and stuff like that. So here were
and then here's after.
So here were a few of the kinds of problems that we were dealing with here. Let me actually expand my Zoom here so we can see that. All right, so here's what
Brian,
we're gonna run
a Zoom call.
Brian, we're gonna no stop that. Okay, so Brian, you said in your last math assignment on Friday, you were going through some decimals that were okay. Here's some models. Okay, now everybody's fine. Okay, let's move on. Yeah. Are you done? So first couple kind of problems that she was doing on Friday's assignment was that she saw block setups like these where they were filling in a certain decimal portion of the block. Okay, well wait, well this still fits too. Hear me out. Okay, I got it. We'll get those in. Okay, we'll get it's fine, it's fine. So here's the setup. They give you where a certain decimal portion of this 10 bar is filled in. The next block in the bar is not completely filled in, it's only filled in partially. The question was, what decimal, 0. what does this stand for? Okay? So how much does it end up standing for there? What decimal could I make out of this according to what's filled in?
$100.
Well, wait. Give me the exact number first. Okay, we'll get to the place value in a minute.
5,800.
Okay, 5,800s. Okay, the idea being the 5 coming from this because since the bar is broken up into 10 equal pieces, that means that this is tenths, meaning that every single one of these is 1/10, 1/10, 1/10, or translated as a decimal, 0.1. Oops, if I write the decimal correctly myself. Okay, so we got that. So it's 0.1, 0.1 all the way down. There's 5 of those.
Yeah.
This next tenth was not completely filled in, and it got broken up into 10 pieces on its own. That gets into the hundredths position. The way that breaks up, there's 8 of those. That's where that came from. And then, as Brianna said, writing that out in words, that represents 58 hundredths. Okay. Whenever you read a decimal out in words, you always write it according to the furthest decimal place that the number reaches. Since this gets to the 100. Okay. You chill. Come on.
It's funny.
Fly back into this consciousness. Okay, they left. They've gone. They're okay. Everybody's safe. They're all happy.
Partying.
Okay, all right.
They're partying in the helicopter while the guy dropped.
Okay, just
okay.
I got.
Okay, so
ends of bit. Okay.
It's just so
all right.
funny.
So that's the way that goes. Since this gets to the hundredths, the furthest place it goes, that's how we read it there. Okay, just to give you another one real fast. Okay, what if we got this? Okay.
Okay, you could erase them.
What if instead? What if you have one that's like this? Okay, here's our 10 block and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What if we got that? Okay, and then we expand this one here. Sorry. Don't mind the okay 1. 6, 7, 8. No think music required. It's just drawing time. Okay.
I don't have any drawing music, so I'm playing the best music I could think of.
Thank you, I appreciate it. Okay. So now get this one here. All right, what decimal we see this time? And see what decimal you guys come up with. So we know it's 0 point. Okay. All right. She's writing it over there. All right. 0.3 because 3, again, this is tenths and 3 of them are filled in. But now this time, the next one's been broken up into not just tenths, been broken up into 100 pieces. Okay. So she's got that. So the idea is then that as far as decimal place go, she's got tenths. And then this would be hundredths. Okay. 10 times hundredths makes now. And this is the correct decimal because there's 64 out of these 100 filled in. That determines the next 3 places. And that translates to 364 what? What decimal place is that?
Thousands.
The thousandths, yes. So that's how you read that. Okay. And that's how that reads over there. Okay, so that's how you want to be able to translate those numbers. So we did that. Okay. Now, you also talked about how you had some problems in your thing where you had to deal with our old friend, the power of 10 again, and that's what our game is going to be based on a little bit.
Yes.
Okay, so we'll get to that in a second. But here, just to stress it, okay, here, Brianna, as you showed the example here, okay, so if you have the decimal 0.5, if you go to, it's okay, so don't worry. I'll get us out of this, don't worry. Okay, so at the 0.5, if you multiply that 0.5, Brianna, by the power of 10, what are you giving it to me for?
You said we need to.
I thought you were. Aren't you texting
I don't know what to say.
Tell her we were. Oh, never mind. We'll tell her. We'll tell her later. Tell her to watch later after we're done.
What?
If you're you'll see. Multiply the 0.5. No, just all right. Not now. Okay.
It's like we're playing hot potato, just passing the phone around.
Okay. 0.5 times 10, what happens? What happens to the decimal every time we multiply by 10?
It gets bigger.
Okay, but what happened? What do we do with the decimal point to make the number bigger? Where does it go? Where?
To the right.
Okay, it's gonna go to the right, and it goes right one place for every 0 that you have in the thing. So since there's 1 0, you move it over one place. What number do you end up with? Right.
Oh no.
No, the other. No, it's already that. So you get 5 there. Okay.
Because I'm leaning. That's why
5
it looks
points.
so
Okay,
bad.
no, it's okay. All right. So 5.0. I'm sorry. Yeah, I got. Sorry, I have to move this. I don't mean to.
No, it's.
I don't mean to get silly with that. Okay, so you get 5.0 out of that. So that's So that's what it would be. Brand, come back here. So that's what it would be if it was times 10.
I am back here.
Will you get up? Yeah, come on. What if it was times 100? 2 zeros would mean it would go 2 places to the right. What number would that make? It would make 50. Okay, and times 1,000. 500 right there. Okay, all right. But then, what if instead you were dividing it by 10 instead? Or again, that would be the same as multiplying by 1/10, whichever way you want to look at it. Because now where does the decimal have to go? Right, back to the left. So it goes one way this way. To fill in this empty space that now sits right there, you throw in an extra 0. So now it's 0.0. It's 0.05 or 500ths. If you divide that by 100, it goes back another place. What does it become? Okay, 0.005.
Wait, why are you closing
5 thousandths and
why
stuff
are you
like
making
that.
like closer?
And same thing, if you divide by 1,000, it goes back yet another place.
Yeah.
And what is this? This is 5 what? What's wait, here, rewrite your 5 there. I'm sorry, I scratched it out. What? How do you read that? That's 5. What decimal place is the 5 in?
10,000.
Yeah, so it's 5 10,000ths. So that's the extreme as to what it is that we do there. Okay, all right. So we talked about all that business. We got into all the stuff with the place values and stuff like that, and doing tens and tens, whatever. And now building off these times and divisions of tens with the decimals. Now let's talk about the game that we tried to do on Friday, and a bit of the rules were a bit lost in the shuffle. And I'll tell you this: this is another one of those games, and I'm trying to do this for every Friday show. I'm trying to set up some type of simple game that, especially as we're stuck here and stranded at home, some simple games you could come up with to help to that you can play. Yes, I got. Okay, sit down.
And there's a little clock.
May I talk? Okay, and these are easy games that you could do with your grade scores and stuff like that to be able to pass the time, to have fun and to still learn. That's what we're about here. That's what we want to do. Okay, so here's the nature of the rules of the game now, and I'll tell you this: all that you really need, if you've got it, and worst comes to worst, there's other ways you could generate this, but if you have a deck of Uno cards, that would be a great tool to be able to use for this particular game. Now, we don't have any Uno cards on us.
Yes,
here. No, we don't. We don't have any Uno cards here. Well, or at least we don't have a full deck because we keep losing them all over the place. So
Minecraft.
yeah, but we don't have them all because you and Joey particularly threw them all over the place. So that was the problem there. All right, so here's how you play. Okay, can I explain the rules here? Okay, so here's how you play the game. If you have an Uno deck, you could do this. Otherwise, you could just use the random number generator on Google if you want to use that, and you could use a simple dice to be able to play the game. This is the dice we're going to use. So I'll explain the setup both ways. Okay, so if you're using an Uno deck, what you need to do is you need to separate the decks, separate all the number cards out of the deck, all the zeros, ones, twos, all the way through 9. Separate those. Then in another pile, separate the skip cards, the reverse cards, and the draw twos. And in the third pile, separate the wilds and the wild draw 4s. Okay. So, and here's what you're going to do with each of them. First, starting from the number deck, you're gonna shuffle those number cards and randomly draw the 3 numbers. So whatever the first 3 numbers you get are. So in my number generator here, okay, I'm starting with an 8. Okay, starting with and I got a 9. Oh geez, I'm getting a high number to start with. Then a 7. Oh wow, I got a really high number to begin with. Okay, so now what's then going to happen is after you've drawn those 3 numbers, what you'll then do is you're going to then draw from the pile that has the skips, the reverses, and the draw 2s. Depending on what you draw, you're going to place a decimal point somewhere in this number in the appropriate position. Here's how that's going to work. Okay, if you draw a skip card, okay. If you draw a skip card, that means you're going to put the decimal point right here at the beginning of the number. That would make this 0.897. If you draw a reverse card, okay, that means you're going to put it here. So to make it 8.97. And if you pull the draw 2 card, you're going to put it there and get 89.7. Obviously, this is the one you want. That's going to give you the biggest number possible here. Now, if you don't have your Uno cards and you're instead just drawing random slips of paper and you have dice available, here's the translation for the dice, and this is what we're going to do here when I roll the dice. If you're using a dice instead to decide this, okay, what you're going to do is if you roll a 1 or a 6, that would be the decimal going here. If you roll a 2 or a 5, the decimal goes here. And best scenario is roll a 3 or a 4, and it goes right there. I'm using those pairs of numbers because they are on opposite sides of the dice. It keeps it nice and fair. Okay, so I am going to now flip my giant dice in the air. I'll hold up to the front of the screen, whatever happens to, I'll shuffle like this and throw it up, and then I'll just flash it like that. Whatever I get, that's the roll of the dice. So, and I get a 5. Okay, so that means my decimal is going to go right here. So I have 8.97. Now, at this point, you have a choice. You can keep this number, and that is your score for the rounds. Or if you feel a little gutsy and you want to take a risk, you could risk that and try to see if you can multiply it times 10. Now, if you're using the Uno cards, here's the rule for that. If you draw, okay, this is now where you draw from the wild cards. You lay out all the wild cards, shuffle face down at random, and you draw one. If you pull a wild draw 4, what that means is your number here, you get to multiply it by 10. That would make this 89.7, and that would be your score for the round if you risk it. But if you draw a just plain wild, you go back by the power of 10. In this case, giving me 0.897. Not so good a score. If you're using the dice, for this, the equivalent would be to get the times 10, roll an even number, the penalty of division of 10 if you roll an odd. Okay, so there's your translations depending on what materials you have available for you, so you can play it both ways. Okay, each person plays 5 rounds of this, and at the end, you add up all of your scores. Whoever has the highest total score, so you get to practice adding decimals too with your 5th grader and everything. So whoever has the highest total score, they are the winner. So in my case now that I've explained everything, let's go through the actual motions. So 8.97 is my score, whatever. You know what? That's a pretty high, even though it's only it's in single points. It's a pretty high one. I'm going to keep it. All right, so I'm going to keep the 8.97. Whoops, write that over there, and I'll leave that as my rounds 1. So we'll see where it is that ultimately comes to. We'll play that out. Okay, so now let's see what Brianna gets for hers. We will randomly generate the numbers here. Okay, Brianna's got as her random numbers 255. So 255. And again, let's now roll and generate the dice here. What? Oh, that's right. She was doing this. Okay, got it. She was taking her ladybug pillow pet and rubbing on it for good luck. she's ready for Vegas tomorrow, folks.
What?
No, she's not. Stop.
What?
Bop. Okay, a 4. Ooh, look at that.
Yay,
4. Okay.
Yay.
So you've got right now 25.5 is your score. So the question, I kept the 8.97. So your question, you want to keep that, or you want to try to see if you can make it 255?
Oh, that's a tough choice.
Play or pass? What would you do, folks?
Oh, what the hey? This is the first round. I can't. I'm
She's gonna risk it. Okay,
oh,
all right.
God.
All right,
So
you tell me when
wait, do I need an even or an odd?
You want an even to go by.
Even.
To
Wait!
go okay.
Even.
Okay. All right.
Rub,
okay, you tell me when to roll. All right. You tell me when to throw it.
Go!
Ah!
Dang it!
So she goes back to 2.55. Okay, it's early.
It's fine.
Okay.
It's early in the game. This doesn't
like
matter
I said,
as much.
we got 5 rounds, so we're all good.
Dang it,
We'll get it all in place there. Okay. Okay, so I'm sorry, I'm just okay, so let me bring it back up here. Where's my random number generator? Gotta get back up here. Okay, can you stop that? Okay, Jaws, sit down while I get my next numbers here. I've got 842. Oh God, you remember that joke too. 842. Okay. All right, here we go. Come on, give me that 4. I only got a 1. So now I've got 0.842. Okay. I gotta try to at least. I'm gonna risk that. I gotta at least try to make it 8.42. Of course, it could be 842 10,000ths if this roll goes bad, but I gotta give a shot at it or whatever. So come on, go. Bah! Shoots. Okay. All right. So hey, that's the risk you take. And no, the 0 goes there. 0.842. Okay, so we got that. Oh well, it happens. All right.
My turn.
Okay, here we go. Your numbers. You've got N8, 1, 3.
Ooh.
Okay.
This
Oh,
has
by the
potential.
way, I will give. By the way, one rule I forgot or whatever. Okay, just to make the game a little bit more fair and stuff like that. If when you're either drawing your slips of paper for your numbers, or if you're drawing with Uno cards, if you get a 0 for the first number, yeah, just put it back in the deck and draw again. The zeros can show up anywhere else, but just to be a little more fair, 0 will not go in the first place. So the first digit will always be 1 through 9. The other zeros can show up anywhere else though. Okay, so we got that. Okay, so let's see where this is yours. This is your second round.
Oh my gosh.
3.
Yay!
You got it again. Look at this. Oh wow.
I'm gonna keep it.
She's gonna keep 81.3. Okay, so she got that. All right. High score. Okay. That's good there. Okay, let's see what she got here. I've got 1, 4.
I didn't even have
geez.
to rub a ladybug on the dice.
Okay, 1, 4, 2. I didn't get such a hot one this time for my third one. Okay, let's see. Okay, move over. Chill.
You didn't see it, but it bounced on the wall.
Again?
Onto this box we have next
0.142. I gotta risk that. I can't keep that.
This is next to
I gotta
us,
at least
and it,
try to get
bounced
even there.
into
Come
that,
on.
and it was so funny.
Come on. Really? She's loving this because in our initial attempt at this, I beat her
really
last
bad
time.
Luck, so now I'm really
Anyway,
happy.
okay. Well, I still got 2 more rounds to go. Okay, your digits. You've got 4. Oh, okay, wait. Okay, I know what happened.
What?
I know why we weren't getting a zeros here as we did it. Okay, I've got the digits set up wrong here on this. Okay, all right, we'll fix it for the next one. Okay, you got a 416. Either way. Okay. I mean, it doesn't change. It doesn't change the.
Okay, well now it's my
It doesn't change
turn
the presentation. We're just being a little more
Now
fair.
it's my turn to handle the dice. I want to turn the flip.
All right, I don't want you. No. That's what I'm saying. I've got it such a way that I'm trying to like.
Okay, no, I got it.
Don't worry. It's fine.
I got it. No, I want to do it.
Just let me, please.
Okay,
just trust me.
Hey.
It's only because okay. All right, that's it.
Rub,
Okay,
rub,
go.
rub.
It's only because the dice is big, and I don't want it bouncing all over the place. Here. 5. Okay, so you got 4. So you got 4.16 right now. Play or pass.
Play.
You're gonna
Risk.
You're gonna risk it. Okay.
Rub.
Okay. Tell me when.
Now. Okay.
Not that time. Okay. Odd goes back. So you're at 0.416. Okay. All right. So get that off me. Come on. Chill there. All right. Let's see what I got. Okay, come on. I need big numbers. 824.
No. Reverse.
Okay, stop. No, stop that.
That's potential for big money.
I need a high score. Look at me. I'm
No,
languishing. I haven't even gotten to 10 points yet.
No. Reverse.
Hey.
No.
All right.
Does that mean you're beating
I've got
me?
82.4.
No, that means you're in the 90s.
Now the question is, all right, do I try for 824?
Yes.
I'm good. No, I'm
Yes.
gonna hang on to it. I need a big score. I gotta hang on to that and keep what I got here. All right, so there's my fourth one. All right.
Imagine I just get all 9s.
You could. You never know. You got 3, 5, 7.
No.
Well, hey, no wait. That's still not bad if you get. Tell me when. Tell me when.
Step.
6.
No. Risk.
Okay. Try to at least make it 3.57 to kind of narrow the gap here. So run.
Step. No.
We are bad at risk today. All right. 0.0357. Okay.
Again.
All right. Final rounds. So we see where it goes here. But it is pretty close here because even in spite of this, you've got about 84 and change. I've got 91 and change. So it's still very close between us. The right numbers could make all the difference. I get as my digits. I get 711. What happens if you dial 711? I know 411 is information. I know 911 is emergency. What does 711 do? It doesn't do anything? Okay.
Do you just call some random area code?
Probably. Who knows? I am not promoting crank calling.
Crank?
leave that to Z100 and the phone tappers.
What's a crank call? You said a crank call.
Ooh, boy.
No! Risk!
I'm keeping it.
No!
All right.
I need all
so let's see what my total is as we add it all up. So you add up according to place value. If you want to throw in the extra zeros to line up all the decimal points, because that's what you need to do when you add. So we'll do that. So let's see. 2 and 2 is 4. 4 and 4 is 8.
Why don't you just risk it?
7, 8, 1, 6, 8,
lead.
16.
Really,
yeah, but I could open the door for you if I mess up. And we've been messing up quite a bit.
Good.
There's 16 with a 1. There's good. 10, 15 there. So there's that. 8 and 2 is 10. There's 12, 1, 16. So I finished with 162.5684 as my final score. All right, so you need some high numbers, and you might need to take the risk. Let's see your digits. Let's see first if you get high enough digits here. You got 6, 3, 4.
Oh.
All right. Okay. You need the 3 or the 4 right now. Otherwise, it's not going to work. And you need the 3 or the 4.
Oh, gosh.
Watch it.
Rub. I need extra rubbing for this one. Rub.
Okay, Chip. Okay.
Rub,
all right. Okay.
We're not done yet. Rub. And then an extra jaw munch. No.
Okay, so
okay.
Come on, you're bumping into the board here.
I think we're good now.
Keeps moving. Okay. Someone.
Stop.
Oh, she's still alive. So 63.4. Now let's see. The key is whether this is enough or not to win. The thing is, let's see, you've only got like 84 here, and I've got 162. So you're a little less than 80 behind. So this alone is not enough. You have to risk it and hope for the even in order to win. The drama, folks. The drama of the final roll.
I need rubbing. Rub.
Okay.
Rub.
Ladybug's in there.
Ready.
All right. Okay.
Ready.
Okay.
Stop.
She wins! She got the 6. She wins!
Oh my
634 whole points.
Yay!
Line them up. Throw in the extra zeros so all the decimals match. She finishes with 7, 11 there. 6, 7, 10. She's all happy.
Did it.
1, 5, and 4 is 10, 13. 1, 3, 4, and 8. And 71 there. 718.30 and 3,017 10,000s. Brianna is the winner. clearly and emphatically, she is happy. She is excited. So you can have a lot of fun to get with this. Like I said, it's simple game with being able to write and use decimals and a little bit of just like simple
ladybug magic.
Yeah, exactly. Ladybug magic, and just simple little risk game of chance and stuff like that. So very simple to play. And like I said, and look at all the math concept that you can get out of it and teach along the way. So it's really good to have fun with. I strongly recommend. And again, nice little way to pass the time too. So go ahead and play it yourself. I promise you'll enjoy it here. All right. So with that thought in mind, okay, we're gonna get out of here, and hopefully all this took and stayed and retained, and if it did, okay, we've tried in our basement, we've tried up in my room up on our top level. Now we're in the living room, and I've got the Ethernet cable directly attached to our router. So this way we could try to hopefully see it. This has got the best feed possible, and hopefully it all took. And if it did, this is where we're staying. Okay, and this is where you'll see us at 2 p.m. this Tuesday, Eastern time at our normal time. We'll be back to Tuesday and Friday like we normally are. Like I said, this was a special reshoot of the whole business here. Okay, so if you enjoyed it, please give it a thumbs up. Please subscribe to the channel. Help us out and do whatever it is you can to spread the word about what we're doing here. We are determined to give you the best math content and entertainment possible. Oh, here's our thumb war again. This is how we ended on Friday here.
Yes.
We'll see you on Tuesday, folks. Take care. Have a good one.
Joey's attacking.